For the last few years, local AI has had this weird reputation. It was powerful enough to be interesting, but not always powerful enough to replace the tools people actually used. You could run a model on your own machine, you could chat with it, you could maybe use it for coding, writing, summarizing, or private documents, but there was always a catch. The model was too weak, the setup was too annoying, the hardware requirements were too high, or the experience felt like a science project compared to using ChatGPT, Claude, Gemini, or any other polished cloud AI tool. And then Meta did something that makes this whole local AI conversation feel very different. Meta released Muse Glimmer, an open-weight AI model that is reportedly designed to run on a normal laptop or PC. Not a giant data center, not a rack of GPUs, not some theoretical future computer that costs more than a car, a regular consumer machine. And that is the part that matters. Because when a company like Meta starts explicitly aiming open-weight AI at personal computers, local AI stops looking like a niche hobby for people who enjoy configuring backends. It starts looking like a real product direction. In this video, we are going to talk about why Muse Glimmer matters, what open-weight actually means, why laptop AI is such a big deal, and why big tech may be quietly preparing for a future where more AI runs on your own hardware. The easy headline is, Meta released a new AI model. But that is not the real story. AI companies release models constantly. Now every week, there's a new benchmark chart, a new leaderboard post, a new model card, a new this changes everything thread, and usually 3 people arguing in the comments about whether it is actually open source. The interesting part here is not just that Meta released another model. The interesting part is the target. Muse Glimmer is being described as an open-weight model made for normal laptops and PCs. That positioning is important because it tells us what Meta thinks the next stage of AI might look like. The biggest AI companies have spent the last few years trying to convince everyone that intelligence lives in the cloud. You type into a website, your prompt goes to a data center. The model runs on expensive infrastructure you will never see. The response comes back and you pay with either a subscription, your data, your attention, an API bill, or some combination of all 3. That model works, it is not going away. The best frontier systems are still going to need enormous compute. But local AI changes the relationship. If the model runs on your machine, then your computer is not just a window into somebody else's AI. It becomes a place where the AI actually lives. That means lower latency, that means better privacy, that means offline use, that means no per token API bill for every small task. And most importantly, it means users and developers can build around AI without being completely dependent on a single cloud provider. That is why Muse Glimmer matters. Not because it magically ends cloud AI, but because it is another signal that the industry is moving toward a hybrid future. Some AI in the cloud, some AI on your device, and a lot of interesting work happening between those two worlds. Now, before we go any further, we need to be careful with the language. Muse Glimmer is being described as open weight. That is not always the same thing as open source. In normal software, open source usually means you can inspect the source code, modify it, build it yourself, and redistribute it under the license terms. With AI, the situation is messier. The model weights are the learned parameters of the model. They are the final artifact produced by training. If a company releases those weights, you may be able to download the model, run it locally, fine-tune it, or build applications on top of it. That is extremely useful. But it does not necessarily mean you have the full training data. It does not necessarily mean you have the entire training pipeline. It does not necessarily mean you can recreate the model from scratch. So open weight is a narrower claim. It means the parameters are available, and in practical terms for a lot of developers and local AI users, that is still the thing they care about most. If you can download the model and run it on your own hardware, that changes what you can build. You can test it privately. You can use it without sending every prompt through a third-party API. You can package it into local apps. You can experiment without waiting for permission from a platform. So the distinction matters. Open weight is not the same as fully open source. But open weight models can still be a massive win for local AI, and that is why Meta's decision is interesting. There is a huge psychological difference between this model can run if you have enterprise hardware and this model can run on a laptop. The first one is technically impressive. The second one feels accessible. That accessibility changes the audience. If a model needs a giant GPU server, the real users are companies, researchers, and infrastructure teams. But if a model can run on a normal laptop or PC, suddenly the audience becomes much larger. Students can try it, indie developers can build with it. Small businesses can run private workflows. Creators can use it for editing, brainstorming, coding, and planning without another subscription. And technically curious people can experiment without renting cloud GPUs. That matters because local AI adoption is not just about benchmark scores, it is about friction. For most people, the best model is not the model with the highest number on a leaderboard. The best model is the one they can actually use. It installs easily, it runs fast enough, it handles useful tasks. It does not destroy their battery instantly, it does not require a weekend of debugging, and it feels reliable enough that they come back to it. That is the bar local AI has to clear. Not, Can it beat the largest frontier model? Most local models cannot. The better question is, can it handle enough everyday work that people stop reaching for the cloud every single time? That is where laptop optimized models become dangerous. Not dangerous in the dramatic sci-fi sense, dangerous to the business model of cloud-only AI. Hey, don't forget to like and subscribe for more like this. Now back to the video. At first, it might seem strange. Why would a big tech company release a model that people can run locally? Wouldn't Meta want everyone using its hosted products instead? The answer is probably both. Meta has always had a complicated relationship with open AI releases. The Llama ecosystem became one of the most important forces in open weight AI. Developers used it everywhere. Startups built on it. Researchers fine-tuned it. Local AI tools supported it. And even if Meta was not directly charging every user per token, it gained massive influence over the AI ecosystem. That influence matters. If your model becomes the default open model people build around, you shape the tooling. You shape the developer community, you shape expectations, you shape what good enough means, and you give the industry a serious alternative to closed API-S from OpenAI, Anthropic, Google, and others. There's also a hardware angle. Meta wants AI inside everyday products, phones, glasses, messaging apps, creator tools, personal assistants. If AI is going to feel personal, responsive, and always available, it cannot always wait for a data center round trip. Some of it needs to happen locally, some of it needs to be private, some of it needs to be fast, and some of it needs to work even when the network is unreliable. So a laptop-ready open weight model is not just a developer toy, it is part of a broader direction, AI that can live closer to the user. Now, I do not want to oversell this. Cloud AI is not dead. The biggest models are still going to live in data centers. If you need frontier reasoning, huge context windows, advanced multimodal work, massive agentic workflows, or the highest possible coding performance, the cloud will often win. There's no magic trick that makes a normal laptop equal to a cluster of high-end GPUs. Physics is still annoyingly real. But local AI does not need to beat the cloud at everything. It only needs to be good enough for enough tasks, and that is where the shift gets interesting. Maybe your laptop model handles private notes, maybe it summarizes PDFs, maybe it drafts emails, maybe it generates simple code, maybe it searches your local files, maybe it classifies documents, maybe it acts as a fast assistant inside your editor. Then when the task is too hard, you route it to a larger cloud model. That hybrid workflow makes a lot of sense. It saves money, it improves privacy, it reduces latency, and it gives users more control. The future is probably not all local or all cloud. It is local first when possible, cloud when necessary, and every new laptop capable open weight model makes that future more realistic. For developers, this is one of the most important parts. Local AI lets you build products that do not require the user to send everything to your server. That changes the design of applications. Imagine a Notes app where the AI runs directly on the user's machine. Imagine a coding assistant that can inspect a private code base without uploading it. Imagine a document tool that summarizes contracts locally. Imagine an internal business tool that can run on company hardware with no external API dependency. This is not just a privacy feature, it is a deployment feature. Cloud AI has a cost structure. Every request costs money. Every token costs money. Every user increases your bill. With local AI, some of that compute can move to the device the user already owns. That does not eliminate cost. The user still needs capable hardware, the developer still needs good engineering, but it changes the economics. If more useful models run locally, software developers can create AI features that feel more like normal software. Install it once, run it anytime, use it heavily, and do not think about every token as a tiny invoice. That is a very different mental model, and it is one reason open-weight laptop models matter. The big question is not whether Muse Glimmer beats the largest closed models. That is the wrong frame. The question is it useful enough, small enough, and accessible enough to push more people toward local AI? Because if the answer is yes, then the model is part of a much bigger trend. Open models are becoming more capable, consumer hardware is becoming more AI ready, local runtimes are becoming easier to use, developers are building better interfaces around them, and users are starting to understand the value of having an AI system that is not always rented from a cloud provider. That combination is powerful. Not because local AI replaces every subscription tomorrow, but because it gives people a choice. And in AI, choice is becoming one of the most important features. Meta releasing Muse Glimmer is not just another model announcement, it is a signal. Big tech is paying attention to local AI. Open weight models are getting aimed at normal consumer hardware, and the old assumption that useful AI must always live in a data center is starting to weaken. That does not mean everyone should cancel their cloud AI subscriptions. It does not mean your laptop is suddenly a frontier lab. But it does mean local AI is entering a new phase. The early phase was, can we run this at all? The next phase is, can normal people use this for real work? And if models like Muse Glimmer keep improving, the answer may increasingly be yes. So the real story is not just that Meta released a laptop-friendly, open-weight model. The real story is that local AI is becoming normal, and once AI becomes something you can run on your own machine, privately, cheaply, and without asking permission, the entire AI market starts to look different.